The ability to determine precise position anywhere on Earth has transformed our world. The way we visualize information, how we navigate, how we build, in the way we do almost everything. It all starts with a simple mathematical formula. Velocity equals distance divided by time. To calculate position, we must first measure the distance a satellite signal travels to a GNSS antenna, and the time it takes to do so. Therefore, we need to rearrange that formula to distance equals velocity times time. Since the time on the receiver and the time on the satellite are synchronized, there is a difference between the time that is on the receiver and the time received from the satellite. Assuming that the signal travels at the speed of light, we now have the pieces to solve for distance. Using a method called trilateration, we can solve the distance to 4 satellites. And since we know the location of those satellites, we now know the location relative to those satellites. If that wasn't difficult enough, the real world is full of errors that complicate things and must be addressed in the position calculation. Errors occur for a variety of reasons. Since a satellite signal is very weak, they can be delayed by conditions in the ionosphere and troposphere. They can also be reflected off of trees, maybe some buildings, basically extending their journey to the antenna. Errors in satellite clock and satellite's orbit all need to be factored in. At Novatel, we are focused on all details affecting the quality of position measurement and have developed technology to mitigate errors. We start with hardware design. The quality of the hardware components used to build a GNSS receiver are vital to positioning performance. Some components are so important that we design them ourselves. How they work together drives functionality, cost, and size. How we develop our software and firmware to turn satellite measurements into usable position is critical. These design choices are what differentiates a low-cost, low-performance GNSS chipset used in your phone and other consumer navigation devices from the receivers used in high-performance applications. Since our OEM receivers are multi-frequency and multi-constellation, you know that they will deliver peak performance for many years to come.